Hi everyone, and welcome to episode 1 of Battleships. In the previous episode, we initialized Git and set up our skeleton main Python file. In this episode, we're going to start work on our one-player game of Battleships. We're going to ask our user where they want to shoot on the command line, parse their input into some coordinates, and then display their shots on a board in glorious ASCII art. As last time, I've written some checkpoints that we want to achieve this episode. So as I said, get input from player, parse it into some X and Y coordinates, then render an empty board, and then render that board with the shots that our user has taken in it. Let's start simple. We'll just ask our user where they want to shoot. The way that you get input in Python is you ask them using the input function. So you can say, where do you want to shoot? And then the user will be displayed this string. They'll type in some input, press enter, and then whatever they type in will be stored in this int variable. Just to show that it works, we can print that input right back to the user. So let's check that out. So where do I want to shoot? 1, 1. Great, and you can see that it prints back 1, 1 to us. However, this is just a single string. This isn't any use to us yet. We need to convert it into some coordinates that we can work with and manage. And in particular, we want to convert it into the x coordinate and the y coordinate. And if we are asking our user to give us their input with x, y coordinate, then a good way to split that into its constituent components is using a method called split. And the way that works is you pass it the character you want to split on, and it returns you an array of all of the substrings of it. So if they pass in 1, 1, it will give us an array with their x and their y coordinate. We can actually use a nice little parameter deconstruction syntax that Python has. And if we write this, then the first element in our array will be assigned to x, and the second element will be assigned to y. Just to make sure this is working, let's print x and then print y. Where do I want to shoot? 1, 1. Great. Try it again with different numbers. And you can see that it's parsed it out into the x coordinate and the y coordinate. However, that's not all, because these are still strings. They're strings where the characters are number characters, but they're still going to behave as strings. And to show you what I mean, let's see what happens when we do x plus y. What we really want is for this to give us back 5. It's actually going to give us back 41 because they're being added as strings, where it just glues the two strings together. Fortunately, it's easy enough to convert them into integers that we can use to represent actual coordinates. And let's do that by renaming these to x string and y string, just to make it clear what they are. And then we can use the int function to pass them like this. And this simply turns the corresponding string into its integer form. Now if we do the same thing, we get x plus y is 5, which proves that they're acting as integers. One tiny thing I note is that it's a bit of a shame that our user has to type on the same line that we asked for their input on. I think it would be nicer if we added a new line in between. And the way you can do that is with \n, which represents a new line. We don't need to say hello anymore. Where do I want to shoot? And you can see our user gets to write on a new line. Great. So we're getting input from our user. Now let's move on to rendering a board, as I mentioned. Let's split this out into a new function, because a separate function that is just responsible for rendering and printing to the screen. This will come up a lot, this idea of isolating pieces of functionality and wrapping them up inside functions or classes or what have you that are only responsible for that one thing. So when we're printing a board to the screen, I think we should make it look something like, just open up this little Scratch file, maybe something like this, where we'll have a nice little header, and then the edge of the board goes here, and then a footer at the bottom. And then when we want to print out coordinates, shots that have been taken on it, we can maybe print X's for now to show that the shot has been taken. If we just start with this empty board, what are we going to need in order to print that? What do we need to know and pass into our render function? I think there's only two things. There's the width of the board and the height. And then we can start by printing the this little header across the top. So we want, that's going to be a plus in the corner. And then we want to print a dash for each element of the width. So this little syntax will print, if this is 10, this will print 10 dashes. And then we want to bookend it with another nice little plus. So let's check that that works. And in fact, let's call this up here because we don't want to have to go through all of this stuff in order just to test our function. So if we do this, that should be, and it looks like it is, a plus, then 10 dashes, then another plus. So that's a good start. Now let's print the pipes along here to represent the middle of the board. And we're going to need to do that once for each unit of height that we have. So we can say for I in range board height, we're going to want to print something broadly similar to our header and footer, just with slightly different characters. Instead of a plus, we want a pipe, and then instead of these dashes, we just want spaces. And then, well, before we go any further, let's just check that works. Cancel that. Oh, it doesn't work. What have I done wrong? You can see that on line 7, I opened the parens, but I did not close them. That looks good to me. They line up nicely. Now all we need to add is that footer on the bottom. And in order to avoid repeating ourselves here, a tiny little thing, we can extract this out into a variable. And then instead of having to print out the same thing down the bottom, we can just print our same variable. This doesn't make much difference, but it's nice because it means if we want to change how this looks, so for example, instead of a plus in the corner, we want to use, I don't know, an @ sign or a hash or something like that, we only have to change it in one place, which is a very nice property to have. So if we run it again, brilliant, our board looks nice. We can actually, we can tick off loads of things. We've done loads of stuff. We got our input from our player, we passed it into X and Y coordinates, we rendered an empty board. Now all that's left is to render a board with the shots printed. So with these X's where the player has shot. Before we do that, let's talk a little bit about our coordinate system. So we're getting these X and Y coordinates from our player. How are we going to translate those into locations on our board? You might be used to coordinate systems starting with their origin, their 0, 0, down in the bottom left. It's actually going to be easier for us if we make it start in the top left here, because we are going to start printing from the top down. So if you think about it, we'll be printing this row first and then going down like this. So it just becomes a bit easier if we can consider this row to be 0. It's actually quite common in programs like this for the top left to be the origin, so we're not doing anything wild. And if we really cared, we could switch things around. We could make it so that this row was the 0. So let's figure out how we can do that. On top of the board width and the board height, we're now going to need to know where the shots have been taken. So we're passing in a shots array, and that's going to be an array, a list of coordinates. So whilst we're testing, let's just hard code some in. So 3, 1, 4, 5, and 8, 1. These coordinates are, we should talk about that briefly. This data structure, where you, with parentheses around it, is called a tuple. It's very similar to a list, except it's immutable. You can't change it. And that's just a useful property for this. And it's commonly used in languages like Python to represent coordinates like this. We're getting shots. Now we have to change up a little bit about how this part of our program works. So we're still going to want to print out our header. That's the same. We're still going to want to iterate through each unit of height. But now we're going to have to do something a bit more careful in order to print out these x's. Let's go through, oops. Yeah, we'll call it like this. No. For each row, we want to go through each column. So say we're considering this row, we're going to, in the same way we're iterating down like this, we're now going to iterate sideways. And as we iterate sideways, we're going to check, is this coordinate, given by what number row we're on and what number column we're on, is there a shot that has that coordinate? If yes, we'll print an X, and if no, we'll just print a blank space. And then we move on to the next square, and the next one, and the next one, and the next one. And we just do that for every single square of our board. And so what that will look like is we'll go for, we can change this counting variable to for y, because this is going along the height. That's going to be our y coordinate. So this one now needs to be our x coordinate. And now we want to say if x comma y, which is the coordinate in the same form as we've done it down here, if that is in shots, so if there is a shot, if there is an element in this array, in this list, equal to x comma y, then we're going to want to print out an x. Well, let's say. And if not, we're going to want to print out a space. And then we can add on the that character into our row. And so by the time we've been through this this loop for our for this particular row, we'll have a list of all of the characters that we want to print in this row. So we can print similar to this, but now we print a pipe again. And now we want to join each element, all of the elements in this list together. We could also have, instead of structuring row as a list, we could have said that row was a string and then just appended these characters onto the string. Both approaches would have been fine. I just happen to prefer the list for reasons I can't properly articulate yet. And then, so the way that we join all of the elements together is like this. And that means join all of the elements in this list with this string in between them, where this string is an empty string. So that's going to do, just as an example, if we said, oh no, okay, I've got to do it this way around. If I wanted to say pipe dot join A, B, C, that's going to give me all of the elements in this list joined by this. And so if I do the same thing with an empty string, it just joins them together. And then once we've joined all those together, we just want to print another pipe on the side like that. And that might do it. Let's have a look. Not quite. Line 22. And I bet what happened is I missed another end parentheses somewhere. Yep, here we go. Missing one there. That looks pretty good to me. Let's double check they're in the right place. So we've got 3, 1. So that's going to be 0, because remember we're going to start, because we're dealing with lists, we start our numbers from 0. We go 0, 1, 2, 3, 0, 1. And then for 8, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1. I'm going to assume that's right. That one's probably right too. That's nice. That looks like it works. The only thing I have to add here is just a tiny optimization that I think it's not at all essential for this program, but it's a nice, interesting thing to talk about. Let's look at this line on line 10 and think about what the computer is actually having to do when it's checking to see if XY is in this shots list. Well, if our shots list is, well, in this case it's this this thing here. If it wants to check to see whether 8, 1 is in this list, it just does it one at a time. It just says, okay, is 3, 1 equal to 8, 1? No. Is 4, 5 equal to 8, 1? No. Is 8, 1 equal to 8, 1? Oh, yes it is. And then it ends up on the first branch. And because we're not doing this that many times, it's only a 10 by 10 grid, and the shots list is not very big. It's only got 3 elements in it at this point, and it won't ever have that many in it. The fact that it has to do this sort of repetitive process over and over again is not such a big deal. But if you think if we had a huge, enormous board and loads of shots, having to check each of these like 100 or 1,000, 100 even wouldn't be so bad, just an enormous number of times would start to get pretty slow. So what we can do is use a data structure called a set to speed up this operation slightly. A set is slightly similar to a list. I won't go too much into the details here, but the important part of it is that it's very quick to check whether an element is present in a set. So whereas in the list our computer had to check each element individually, a set, because of the way it's structured, it can check whether an element is in the set in a single check, like that. If you're interested, then Google difference between list and set, and you can read a little bit more about it. It's not too complicated. So let's create our shots set up here, and all you have to do is this, and that turns this list into a set, and change that into shot sets. The syntax is the same for lists and sets in this case, so we don't have to change anything else. As I said, for our program is just lightning fast already, so we're not going to notice any difference, but it doesn't really cost us anything to do this, and as I said, I think it's pretty interesting to talk about. For our final thing for this episode, let's connect these two things. Let's get our input from our user and pass it in to this render function, just to make sure they work well together. And let's make it so that it loops asking the player for input just forever. I know at the moment our game doesn't have any concept of what a battleship is, or what a shot really means, or how the game ends, or what it means to win, or anything like that. For the moment, all it knows how to do is just ask for input. In order to loop something forever, you'll often use this construction here, this while true, which means do this loop as long as this condition is true. And since this condition is literally the word true, it's going to loop and loop forever and ever. And then we'll want to add into our list of shots that I quietly declared up here. When we start the game, there are no shots, and then every time we go through in here, through this loop, we append a new shot, and then render the board like this. This should just work straight away. What have I done? Oh. I want to shoot at 1, 1. That looks pretty good to me. 2, 2, 3, 3. Let's keep going along that diagonal. 8, 8, 0, 0. Of course, we are kind of vulnerable to our user giving us bad inputs. So we'll eventually want to do something about that. For now, we don't need to worry. but we should write ourselves a little to-do. Deal with invalid input. So that's it for this episode. We've got some input from our user, we've turned it into some coordinates, and we figured out how to start printing that to the screen. All that remains is to use Git and add in our changes. We don't need this scratch file anymore, and we can just commit our work. So we go git status to see the changes, and I happen to have this little GS thing aliased to run git status just to save a few keystrokes, but it doesn't matter. Then you git add dot to add it all, to stage all of these changes. Then git commit to make the commit. So this was episode 1, and what did we do? We get input and render the board. So next time we'll start looking at the battleships side of the game. We'll start working out how we want to represent our battleships in code, and maybe even start printing them onto the board as well. I'll see you next time. Bye.